Hello everybody, welcome to GDYU Shoot 'em Up Unity Workshop. In this workshop we're gonna hopefully be making a shoot 'em up game that looks a bit like this. So an endless shoot 'em up game where you're basically playing as this fighter plane that we 3D modeled in the Blender workshop, and you're shooting down these enemy fighter planes that are flying at you and shooting at you, and you can see you take damage when you get shot. And also, I guess the point of the game, it's like an endless runner, so you're trying to get as far as possible without getting killed by the enemies, and it slowly gets harder and harder the more you play, the more planes come at you, and the faster they come at you. So yeah, this is what we're going to try and make. Hopefully we're able to do that. So let's stop this here, or I can maybe die. There we go, I died. Okay, so let's stop this here. And if you haven't installed Unity, link in the description on how to install it. We're using 2022.3.1, so as long as you're using 2022, it's probably best. But then once you have that installed, you'll be installing Unity Hub and then installing the Unity version in Unity Hub. See editor version 2022.3.1, and then you'll go to new project here, and you'll select 3D URP is what we're going to be using. If it's not at the top here, it might be down in here somewhere, and you have to actually install it. So selecting 3D URP, let's give it a project name. So let's do GDYU Shoot 'em Up Workshop. Select where you want it to go on your PC. Organization, it should just be your Unity username as publisher. Uncheck connect to Unity Cloud. Make sure user version control is unchecked. You don't need those. And then create project. And then it should be creating the project. This will probably take a minute. All right, so once your Unity project is finished opening for the first time, it should open and look something like this. Well, the first thing we're going to do is we're going to click on the README here. It should be open by default, but if not, in the bottom here, we're going to click on README, and we're going to click Remove README Assets, Proceed. It's just bloat that we can remove. And very quickly, I'm just going to explain some of the windows here. First is the layout. So by default, it's set to the default layout. There's a bunch of other layouts here. I actually use the 2x3 usually, but for the sake of the workshop, I'm going to stick to the default. And it looks something like this, but you can change your layout if you want. But the first thing we're going to do here is we're going to look at the bottom window here, the project window. This is basically all the files and assets that are in your project. It's got the assets folder, and then in there it's got the scenes and settings folder. So we're going to create some more folders in here that we're going to use. So to do that, you can right click here and create folder. We're going to need a scripts folder. We're going to need a materials and textures folder, and we're going to need a prefabs folder and models folder, like that. Cool, we'll just set up those folders. We're going to use them all throughout the workshop. All right, now you can skip if you don't want to hear my explanation about what all these windows do. So we just use the project files window, like I said, for all the project files. The other window is the hierarchy here in the top left. This hierarchy is basically, you can see sample scene. This is the scene that we're in, and these are all the game objects that are in this scene. So you see it starts us with some default ones: main camera, directional light, global volume. And you'll see all these game objects that are being selected in this other window here, the scene and game views. So this is the view from the camera's perspective, and this is kind of your overall view of the scene from the editor perspective. And I'll just explain kind of how to move around in the scene view here. So hopefully you have a mouse. If not, a mouse is very recommended for using something like Unity. But if you right click, you go into this like look around mode where you're able to look around like it's a first person game. And then you can use WASD to kind of move around, and you move forward and backwards in the direction the camera's facing, and AD left and right. And then you can use Q to go down and E to go up. So you're basically just kind of flying around in 3D space here. Again, holding right click to look around like this. And you can also use in the top right here this gimbal to kind of switch perspectives if you want to line something up. And you can click on the cube in the middle if you want to switch from regular perspective to orthographic. So maybe you're making an orthographic game or something. But yeah, and you click it again to go back. But most of the time you'll stay in this perspective and you'll just be flying around like this. Cool, that is the scene view. Now the last main window on the right here is the inspector window. And the inspector window, you can see if I switch what game object I've selected, it's jumping around here and has a bunch of different options. These are basically all the options and components that are on and attached to your game object. So in Unity we have game objects, which are all the things in the hierarchy, and then we have components which are attached to game objects. So if we look at the main camera here, you can see at the top here there's some settings to do with the main camera, so the name, tag it has, and then there's the first component here, which is the transform component. Every game object has the transform component, which is basically the position, rotation, and scale of the game object in the world. So you can see the position of the camera here is 1 on the Y, -10 on the Z, rotation 0, 0, 0, scale 1, 1, 1. And then it has its second component is the camera. So these have to do with all the settings to do with the camera. And yeah, and then it's got some other things, audio listener. If we look at the directional light here, it's got a transform component, and then it's got its light component, which has to do all the settings of the light, and global volume has to do with the settings of the global volume, which has to do with post-processing and stuff. We're not going to touch that. So yeah, that's components, and we'll be using those throughout the workshop, and yeah. I think that's all the windows explained, so now I think we can actually get into starting to make the game here. So first thing we're going to do is we're going to change the position of this camera to look at a different perspective here that we want for our shoot 'em up game. So for that, we're going to edit the transform component here. So what we're going to do is we're going to set the position on the Y to 60, which moves our camera up way into the sky. And we're going to set our Z to -10. It's already at -10. Cool. And we're going to set our rotation on the X to 60. And what this essentially is doing is kind of looking down from above, because our plane is going to be like in this area here, and it's going to be flying in this area. So we want to look at it from kind of an above perspective here. And you can see a little preview of the camera in the bottom right here, or you can switch to the game view. Right now it's just a blank canvas with a gray background, which we are going to change right now because we kind of want like a sky blue background. So to do that, we're going to, with our main camera selected in the hierarchy, we're going to go to the inspector here and find the camera component, and we're going to go under environment here. It's already open, and we're going to change the background type to solid color, and we're going to change this background color here to some sort of light blue. You can see right here, this is what the background now looks like. So I'm going to pick like a sky blue color that looks kind of decent. Pretend we're flying over an ocean or something, and we switch to the game view. This is kind of what it looks like. Maybe a little bit lighter, light blue. Something like that. Yeah, maybe we're flying over a giant ocean or something. Okay, good enough. All right. So now our background looks a bit better. We're also going to just tweak the lighting right now, might as well. So for that, we're going to open a new window. We're going to go to Window, and we're going to go to Rendering, Lighting, and that's going to open this window here. And I like to dock it here beside the inspector, so it shows up here. Don't bother with all of these settings. Tons of lighting settings. The one we want to bother with is under Environment, and Source. We want to change from Skybox to Color, and we want to kind of just pick a bluish color somewhere near where we picked before. You're not going to see any really difference right now, but it'll just make the planes have like a blue lighting color on them, which makes sense because our background is blue. So there we go. And the other thing we're going to do is on our directional light here that's in the hierarchy, we're going to set our directional light game object, and we're going to switch back to the inspector here on the right. We're going to change under the light component, the emission from filter and temperature to color, and we're going to change also the color to a kind of bluish color, like that, I believe. Actually, I think maybe just a white color. We'll see once we get the plane in the scene, but I think it's just a white color we want. We'll just leave it there. We just wanted to change it off of this to color. All right. Cool. We just got those settings all set up, and we'll see the differences in the future. Next thing we want to do is we need to bring in our input actions package for Unity. For some reason, Unity does not come with the new and improved input system by default, so we have to add it. So for that, we're going to go to Window. We're going to go to Package Manager, and we're going to change it from in project to Unity registry, and we're going to search for input. I can spell input system, and we're going to install that. And this will probably take a second. The Unity editor will restart. Okay, when this pops up, yep, you can click yes. The editor is going to restart. All right, and once the editor restarts, if you switch the packages back to in project, you should see somewhere in here. There it is, right there, input system. So now it's installed, so we can just close this window. Now, what we need to do is we need to actually set up our inputs. So for that, we're going to go to our scripts folder here in the project files here. We're going to find the scripts folder. We're going to right click. We're going to do create, and depending on your screen size, it'll probably be off the screen here. So I just click this arrow at the bottom here until I see input actions. Click on that. We're going to name it inputs. All right, and then we're going to double click on it here to open it. It's going to open this input actions window. And we're going to, first off in the action maps column here, we're going to click this plus, and we're going to name it player. So it's going to be all our player inputs. And then in the second column here, we got to set up our actions here. So we're going to rename this one here, the action, by double clicking on it to movement. And underneath it here, if you click on this no binding, we're going to change, or sorry, on the movement, with the movement selected, we got to change the action type to value and the control type to vector2. And then I believe we click, now we can actually delete this. I just selected it and clicked delete on my keyboard. Or you can right click delete. I believe now you click this plus, and we're going to do up, down, left, right, composite. Yes, and we're going to name that WASD. So these are going to be our WASD on our keyboard. And then so we got to now map all these controls to a control. So up would be, if we click on the empty area beside path here, up would be W on the keyboard, so I can just click W, and it should like kind of find the button I just clicked, which is W. Down would be S on the keyboard. Left would be A keyboard. Right would be D keyboard. So it should look something like this. All right, so let's just close these, and let's create another action here. So we click the plus icon, and we're going to name it fire. And this is an action type button, and under the binding, we're just going to need space. So search space. And so now the fire button is our space bar on our keyboard. All right, so those are the two movement actions we need to set up: WASD for movement of the plane and space for firing the bullets. That should be good. We can save asset here in the top, close this window, and then if we select the input action map here, we want to, in the inspector here, check the generate C# class and click apply, and that should auto generate this inputs script, which we're going to use in our own script. Alright, so that's the inputs finished. Next, we're going to bring in our fighter plane model so we can see it in the scene here. So for that, we're going to go to our models folder here, and I'm going to have a link in the description to download the model. But if you created a model in the Blender workshop, then you can bring in that model. Otherwise, you can use the one I created. So I'm just going to bring it in here. So you can drag it from your downloads folder or wherever you saved it from Blender. The FBX file, you can drag it into your models folder in Unity. It should show up here. Fighter, you can rename it if you want or leave the default name. But you can see here, here's our fighter model. And in the inspector, you can see all kinds of settings to do with the model. We're not going to mess with anything. What we're going to do now that we have our fighter model in here is we're going to actually bring it into our scene here. So in the hierarchy here, we're going to right click and we're going to do create empty. And we're going to name it player. Okay, and then in the transform here, we're just going to right click on it and we're going to click reset, and that just makes sure it's right in the center of the scene. And then what we're going to do is we're going to grab our fighter model here from our models folder, and we're going to click and drag it so that our mouse is over top of our player empty game object. And what it's going to do is when we let go, it's going to put it as a child of our player. So now the fighter is a child of our player game object. And so what this does is if we move around our player game object, you see it moves around the fighter with it. And it's just a way of organizing game objects. They can be childs of other game objects so that they inherit the position and rotation of their parent. So now we have our fighter model here. We notice that from our camera here, it's facing the wrong way. If we look at it from the game view, it's facing down. We want it to face up. So what we're going to do here is select our fighter game object here, and we're going to rotate on the y-axis 180 degrees to rotate it around. Now it's facing up. Now you can see the blue coloring on the white plane, but it's a white plane right now. We want to make it actually be colored like we did in the Blender workshop. So for that, we're going to need to go to our materials and textures folder here, and we're going to need to bring in those color palettes that we made in the Blender workshop, or they'll also be linked below. I'm just going to bring in here fighter1_green. You can see it's got the color, the checkerboard with our colors, which remember we set the UVs to go over certain colors depending on what color we wanted each face. So now to actually make our plane use this texture, we're going to need to make a material. So what we're going to do is we're going to right click in this folder beside our texture here. We're doing create, and we're going to find material here. We'll name it green fighter. Alright, now with this material selected, if you look in the inspector here, you could just change the color here. You can see colors changing in the preview here. But what we want to do is we want it to use the textures for color. So what you can do is in this little box here beside base map, you can drag this texture into that box. And then now you can see the textures like stretched across this preview here of the material. And so now if we actually apply this material to this game object by selecting the game object and dragging it, actually sorry, you have to open this game object because there's actually two game objects below this game object, which is the fighter model, right, and the propeller model, which is separate because we want the propeller to be able to spin. So with both of these selected, I'm holding shift to shift select the two of them. You can drag the material into the bottom of the inspector here, or I think you can just drag it right onto them. But if you want to get them both have the material with one drag, you can drag it into here, and they both have that material now. They're both this green color with white stripes. And if we look in the game view, you can see it looks good. And now you can see also the lighting on it. It's got a blue tint. I know it's really small, but yeah, I zoom in here. Pixelated because we're zooming in, but you can see it looks good. All right, so that is our fighter model all set up. And now, by the way, just make sure you're clicking Control S often to make sure you're saving, or you can do File, Save. I just do that by instinct, but I'll just mention it. Next thing we're going to do is we're going to do the player movement. So how do we actually get this plane to, fly around in the scene, right? Get them to move around. And for that, we are going to need to make a script. So we're going to go to our scripts folder, and we're going to right click, and we're going to do create C# script, and we're going to name it player. Make sure you name it exactly player before you click enter. Or you can name it anything, but make sure you don't mess up, because that'll I'll explain in a minute. You'll have to fix it in the script because it uses whatever you type here the first time in the script for the class name. So yeah, name it player or whatever you want, but player. And then if we double click on that, I'm just going to quickly check. Yes, okay. You can ignore that. I just want to make sure. So if you double click on it, it should open Visual Studio 2019. I think is still what comes with Unity by default. And it should open your player class. And here you go. Like I mentioned, the name of it should be player. Make sure this matches whatever your file name is. It's a common issue. Make sure these two match exactly. But yeah, so here is our player class. And I'll just explain. There's two functions it comes with by default. The start function tells you right here. It's called the very first frame. And the update function is called once every frame. So this is like your infinite loop, and this is like your main or your start function. All right, cool. So we're just gonna jump right into writing the script here. So at the top here, I'm just gonna make some space, and I'm gonna start off by just making some variables that we're gonna need. So first we're gonna need is a private inputs, player inputs. And if you remember, inputs is that class we made based on the input actions that was auto-generated. So that is this script. We're going to bring that in. And we're going to now need some variables. We're going to make them public so we can edit them in the inspector. Public basically means the variables are accessible and from other scripts and also in the inspector. So we're going to make this variable public because we want it to be seen in the inspector. So we're going to make a public float move speed. The move speed of our plane. We're going to need a public float max speed, be the max speed of the plane, and we're going to need a public float drag. This is what we're going to use to simulate drag and slow down our plane if we're not giving it any input. And then we're going to need a private variable, private because we don't need it to show up in the inspector. Vector3 current move vect. We're just gonna, this is just a variable that we need to use in our movement code in the future. And now if we Control S to save, just minimize this script window, script's gonna compile, and we'll just check here. If we click on our player object and we click and drag our script into the empty inspector here, it'll add it as a component, and we should see our move speed, max speed, and drag. We'll give those values in a bit after we work on the script, but that looks good, so we'll just reopen the script. And we'll start writing some more code here. So in the start function, we need to set up our player inputs. So we're going to do player inputs is equal to new inputs, inputs, plural. And this is just going to call the constructor for that inputs class that was generated by Unity. And then we just need to do player inputs dot enable to enable that class. And yeah, that's all set up. So now in our update function, we're going to actually, this update function is going to get lots of logic in it throughout the workshop. So we're going to make a function that we're going to call. So we're going to make a private void move, and this is going to handle, auto completed on me. This is going to handle all the code to do with moving the plane. And what we're going to do is we're going to call this function in our update function. So update is going to call move, which is going to run all the code and move. All right, so now we're going to write our code that's going to move our plane. So the first thing we're going to need to do is we're going to need to get the our movement inputs. And to do that, we're going to set them equal to the player inputs dot player. That was the name of our action map. Dot movement was the name of the action input that this is right, our WASD is movement, and we're going to do dot read value and vector2, just like that. And essentially this is just reading in our WASD, right? The X is, I believe, AD on our keyboard, and the Y would be W and S, and it'll basically be a value of 1 on the Y if we're clicking W, and -1 on the Y if we're clicking S, and same for the X. And then what we're going to need to do is we're going to need to translate that into a vector3 because our inputs are in 2D space, but our game is in 3D, so we're going to change that to move vect 3D space like this. We're going to do a new vector3 with move input. I'm going to change this from plural to singular. Move input dot x, so that's left, right. 0 on the y because our plane doesn't move up and down, and then move input dot y for forward and backwards. So there we go. We're translating our 2-dimensional inputs into 3-dimensional, even though we're really only still moving on 2 dimensions. The third dimension up and down is just 0. Okay, so now we're going to just do some checks before we move. We want to do is our move vect dot magnitude greater than 0. 0. So are we actually providing inputs? The magnitude is greater than 0. So as long as any key is pressed, it'll be greater than 0. And current move vect dot magnitude is less than max speed. So is our current movement magnitude, which is basically the velocity, is it less than the max speed? So we stop moving if we're at our max speed. So if we are have inputs and below our max speed, we will basically update our movement. So we're going to do current move vect plus equals our movement vector times our move speed multiplied by time dot delta time. So essentially this is taking our movement vector in 3D space, multiplying it by the speed we want to move at, and then we're multiplying it by time dot delta time. This is to make it frame independent because this is being called in the update loop, which is called once per frame. And depending on the computer this is being played on, there could be more frames per second. So we're just multiplying it by time by delta time, which is the time since the last frame occurred, to ensure that it's moving at the same speed for every computer. Okay, so now that we've calculated our current move vector, we need to actually apply it to our plane. So for that, we can do transform dot position plus equals current move vect times time dot delta time. Again, making it frame independent, or basically just updating the position based on this move vect. Now there's one other thing is we want to apply drag to our plane so it slows down if gradually if we let go of the controls. So before this, what we want to do is we want to update our current move vect to equal vector3 dot move towards. We want to move our current movement vector towards vector3 dot 0, and we want to move it at a rate of drag times again time dot delta time, make it frame independent. And essentially what this is doing is it's constantly applying a force to the plane of drag, so it's constantly trying to slow down the plane, but when we're actually applying inputs, it's gonna, you know, overtake that drag. But if we let go of the inputs, the drag is slowly going to move. If you mouse over move towards, it takes in our current movement vector where we want to go, which is vector3.0, so 0 speed at all, at a rate of drag times time dot delta time. So this is constantly going to be trying to slow down our plane, but if we're applying inputs, it's going to overtake that and move anyways. And then we're going to apply that current movement vector to our transform dot position. Okay, hopefully that explanation made sense. If not, you can look it over and try and understand it, because this movement is a bit complex, but that's because we want that drag and floaty effect, which you're about to see. So I'm going to Control S to save this, and then I'm going to minimize this. And in Unity, script compile, we click on our player game artwork here. It has our player script. We're just going to set our values of our move speed to 350, max speed to 75, and our drag to 150. And these are just the values that I've found to feel pretty good. And then if we click play, we should have movement going on here. So yeah, here we go. I got WASD and the plane is moving around. And you can see if I let go of the controls, it kind of floats to a stop. So that's what the drag is doing, right? I'm letting go of the controls, but it takes like a second or so for the plane to actually come to a complete stop. Yeah, it feels good. All right, so, but it looks a bit static and weird, like the plane's kind of just flat, and normally kind of when planes, you know, float back and forth, they actually bank, you know, they bank their wings left or right. So let's make the plane do that. So for that, we're going to stop the game. We're going to go back into our player script. At the top here, we're going to need another variable here because we're going to actually need access to the plane model to make it bank. So for that, we're going to make a public transform fighter model. All right, so we're going to use that variable. This is basically the transform, which is position, rotation, scale of the fighter model. And then we're going to make another function for this. We'll call it private void bank. And this is going to handle all the logic and code to do with banking the plane. We have to make sure that we call it up here in the update function, bank, right after the move function. And then here we're going to start writing our code for banking. So what we're going to do is we're actually just going to copy and paste these first two lines of the move because we need the exact same thing. We basically just want to take in the player input, translate it to 3D, vector 3. And then what we're going to do is we're going to do some checks here. So we're going to need a local variable float bank angle. We're going to set it to 0 default. And then we're going to do some checks if our movement vector dot x is greater than 0. So basically if we are moving right, say, I'm not sure if it's right or left, but if it's greater than 0, say that's right, then we want to set our bank angle to 15 degrees. And else if our movement vector dot x is less than 0, so say we're going left instead of right, we want to set our bank angle equal to -15, so 15 degrees the other way. And then we just got to do some math here and then apply it to our plane. So we're going to do another local variable here, current bank angle. So we're going to calculate, we're going to want to smoothly bank. So we're going to calculate a smooth bank here. So to do that, we're going to do a math function, math f dot lerp angle, which is essentially going to smoothly lerp towards either 15 degrees or -15 degrees. Or 0 if we're not touching the controls at all. You can see what it takes here. So it takes the angle that the value that we want to lerp towards what value we want to lerp it towards, and then the rate. So let me just write out here. So the value that it'll currently be is fighter model dot Euler angles dot z. Euler angles is essentially the rotation, but in degrees instead of radians. And the value we want to bank towards is bank angle, and the rate is 10 is just the value I came up with, times time dot delta time to again make it frame independent. All right, again, a bit complicated math. Basically what it does is it takes whatever our current angle of the plane is and is lerping towards the bank angle, so either 0, 15, or -15 at a rate of 10 times time dot delta time. And then we just need to now apply this to the actual plane model. So we want to do fighter model dot Euler angles is equal to new vector 3, 0 on the x. Remember our plane is rotated 180 degrees, so we just want to keep it at 180 degrees. And then our z is the angle that we want to be setting to our current bank angle. Cool. Awesome. Control S to save, and then we can minimize this. And if we click play now, oh, I forgot one thing. No, don't click play yet. I see I just got the error. So what I did is I forgot to assign the model here to the fighter model. So I need to just open the children of the player here and the fighter. And fighter 1 is the, fighter is the child that we want to drag into fighter model here. And this is essentially the transform of the plane. And this is the transform that we want to adjust the Z rotation on, right, to make it bank like this. Okay. Okay, so now if I click play, I shouldn't get an error, and it should be good. So now if I move around and if I go left or right, you see the plane banks left or right. Looks a lot more natural. Cool. Okay, next thing we're gonna do is we're going to make the propeller spin, because right now it's static. It should be spinning because we're flying, right? We really want to sell that effect that we're flying through the sky. So this should be pretty simple. So once again, jump into the player script, and now we're going to need at the very top here, we're going to need a variable for the propeller transform. So public transform propeller model. Okay, and then now in our update function, just at the bottom here, we just simply need to do propeller model dot Euler angles plus equals new vector 3, 0 on the x, 0 on the y, and just 1,000 is the speed I thought looked good, times, again, time dot delta time. Cool. Simple as that. Control S to save. Minimize this. And let's not forget this time. Let's click on the player game object, and we need to assign the propeller model in the hierarchy. For that, we got to open both children, find the fighter 1 propeller, which again is just the propeller itself on the front here. And I gotta make sure I have the player selected, and then click and drag the propeller model into propeller model. Now, one thing to mention actually is depending on your model, if it's not the model that you're using in the downloads, your rotations may be different. Like it may be actually the X that you need to rotate it on, or the Y that you need to rotate it on. Um, and if that's so, then you might need to change in the script which axes you're rotating on. Same for the banking actually. You may need to change in the script what axes you're banking on. But yeah, hopefully that's good. So now we should be good to play again, and the propeller should be spinning. There we go. Cool. Now it's spinning. So now it's selling the effect that we're actually flying. Cool. All right. So the next issue that I see here is that we're able to like fly off the screen and see like I'm completely. Oh, I just came from down there. I was lost there for a second. So what we want to do is, usually in these games, either you wrap around to the other side when you go off the screen, or you somehow like they don't let you pass the edge of the screen. So we're just going to do the good old like keep them from passing the edge of the screen. And for that, we're going to just go into play mode here. Back in the player script once again, and we're going to set up some logic to prevent the player from going past boundaries. So for that, we're going to need some variables here to set our boundaries. So public vector2 vertical bounds. So that'll be top of the screen, bottom of the screen, and public another public vector2 horizontal bounds. So that'll be left and right of the screen. We'll set these in the inspector in a minute. Then down here in our movement code, we're essentially going to need to do some checks here to prevent us from going past the bounds that we set. So for that, we're going to make some if statements here. Now this is going to get a bit hard to follow, so you'll have to make sure that it's exactly like mine, but we're going to do transform.position.x is less than horizontal bounds.x and move vect is less than 0. And this is the left bound check basically. Move vect dot x is less than 0. So essentially what this is doing is if our position of our plane is less than the horizontal bounds dot x, so basically to the left of the horizontal bound on the left side of the screen, and we're actually giving input on the x to go left, what we're going to do is we're essentially going to instead vector move vect dot x equals 0.5f, which is essentially instead of moving left, we're going to nudge it to move back to the right. So essentially what this is going to do is it's going to make it so that we don't hard stop at the edge of the screen. Instead, it is going to essentially go slightly past the bounds and then float back to the bounds. So it'll be kind of like an elastic, and it'll feel much better. And so this is the left bound. We essentially need to do this for the other three as well. So I'm going to just copy paste this. And for this one, it's going to be transform.position is greater than horizontal bounds dot y, which is the right side of the screen. And we want to be moving instead of left, we want to be moving right. So we're going to change this to greater than, and this is our right bound. And if we're at the right side of the screen, we're going to tell it to move back to the left until we're across the bounds. Okay, we're going to copy this again. Actually, I'll copy this one because it's closer. And this is going to be for our top bound. So instead of position.x, we need to do position.z is less than vertical bounds dot y, which is the top of the screen, and our move vect dot z is less than 0. This is the top bound, and if we're at the top bound, we want to tell it to come back down, so we want to move vect dot z. Okay, I'm going to copy this one again, and we want position dot z is now greater than vertical bounds dot x, which is the bottom of the screen, and we want to be moving down, so move x.z is greater than 0, and this is the bottom bound. And we want to move x.z negative 0.5. Okay, so that was a bunch of just checks that, you know, I figured out with trial and error. I basically just told you the exact checks you need to do. So yeah, just make sure that you pause and have this looking exactly like mine. Cool. So now we're just going to Control S, and we're going to minimize Visual Studio. And now in the Unity editor here, we're just going to select our player, and this time in the inspector, we're going to remember we got to set the vertical bound, so the top of the screen will say 85, and the left and right horizontal bound, so negative 50 would be the left of the screen, I've figured out, and 50 is the right of the screen. We're going to save that, and now if we click play, and we move our plane, we should see it like kind of floats to the edge and then stops, stops, and you see it doesn't abruptly stop, it kind of elastic bands. Cool. The reason why it's not quite at the edge of the screen is because right now we're, if you see the top here, it says free aspect, which essentially kind of just auto adjusts to our screen size. But you see now I'm going off the screen just because I adjusted the window here. So what you want to do is you want to set free aspect to full HD 1920 1080, which makes the window exactly 16:9 aspect ratio. And you can see now it's about the edge of the screen. And because of our camera layout, technically right here is the edge. Our camera is looking at it from a slight angle, but this is good enough for our game here. Cool. So now we have our plane floating around on our screen and staying within kind of these bounds. Awesome. All right, next we're going to make bullets that we can fire out of our plane, and we'll be shooting at enemies eventually. So for that, we're going to go in our hierarchy here, and we're going to right click, and we're going to do a create 3D object cube. We're just going to make the bullets as simple cubes because they're pretty small, can't even tell. And we're going to name it to bullet here, prompt you for the name. If you didn't click, if you did click and it's still named cube, you can rename it in the top right here to whatever you want. Bullet, probably a good name though. You can see here it's kind of just in a random spot here. So we're going to reset the transform by right-clicking on transform here, click reset, and that's going to bring it to the center of the world. Noticing my plane isn't in the center, I'm going to reset it as well. My plane here is now in the center as well, but I'm going to look at the bullet here. It's inside the plane here. Might be a little hard to see. But right now it's just a giant cube. We want to make it more of a bullet shape. So for that, I'm going to set the scale on the X here in the transform component to 0.1, and as well as the Y 0.1. And now it's more of a bullet shape. I'm actually noticing the icon here is kind of in the way. So for that, you can, in the top right here, click on this little drop down and uncheck 3D icons. And that'll just make the 3D icon a nice small 2D icon so it's not in your face. So now we have our bullet here, but it's a gray color here, not very good looking. I'm actually going to turn off the player model for a second. There we go. Kind of looks plain, so we're going to make it look more like a bullet color. So for that, we're going to go to our materials folder here. We're going to right click, we're going to do create material, call it bullet, and we can drag that right onto our bullet object here. Now it's like a white color because that's what we have it set to. We can change the color here to like maybe like a yellowish color here. And we kind of want to make like the shiny bullet. So let's toggle on emission here, make it glow. So we can change toggle on emission and change this to kind of a yellow color. See, it's glowing a bit, and then we can actually make it glow a bit more by increasing the intensity to say like 3, and now it's like now that looks like a fast moving bullet, right? That looks good. Cool. Okay, I'm gonna turn back on the plane here because we want it in the world, and I'm gonna actually, what I'm gonna do is I'm gonna make this bullet a prefab because we want to have multiple of it. So for that, I'm going to go into our prefabs folder, and I'm going to drag our bullet game object from our hierarchy into the prefabs folder, and it's going to make what's called a prefab. And to look at this prefab, we're going to double click on it here, and now we're in the prefab view here of the bullet. Why is the materials? Yeah, I get it's looking white in the prefab view for some reason, but that's okay. Okay, so this is the prefab view. So basically any changes you make to the bullet in the prefab view will apply to all prefabs. So you just gotta make sure that any changes we make to the bullet, we do it in the prefab view. You can also get into the prefab view here by clicking the little arrow beside the prefab. You see it's isolated the scene to only be editing the bullet prefab. Yeah, I'm actually going to delete the bullet here from this scene because we're gonna spawn the bullets in through a script, basically at the guns here. We're gonna make the bullets fly out of the guns. Okay, so for that we're gonna need a bullet script. So we're gonna go to our scripts here, and we're gonna right click in here when you create C# script. We're gonna name it bullet. What this script is actually going to do is it's going to make the bullet fly off into the distance, and then it's going to handle destroying it as well. So let's open this bullet script, and it's just an empty class. Make sure the name matches. And in here, we're going to need some variables. So at the top here, we're going to make a public float bullet speed and a public float bullet life. So how fast we want it to go and how long we want it to last before destroying it, because otherwise we would lag our game if we never destroyed it. So basically in the start function here, we're going to destroy game object, which is this game object, the game object the script is on, which is the bullet. And we don't want to destroy it right away. We want to destroy it after a delay of bullet life. So if you look at the destroy function here, it says it takes the object it wants to destroy, and after float time t, so after bullet life, it'll destroy the bullet game object. But while it's still alive, what we want to do is we basically just want to make it fly in a direction forever. So we want to do transform dot position plus equals transform dot forward, which is a vector 3, a direction vector, which is basically the forward direction, the direction the bullet is facing, multiplying it by bullet speed, so the speed the bullet is going to go, and then again multiplying that by time, dot delta time, to make sure it's frame independent. Cool, and as simple as that, the bullet should fly infinitely in one direction and die after time bullet life. Cool, so let's minimize this. Let's go to our prefabs. Again, we can just look at the bullet here in the prefabs, and we can drag our script, our bullet script into here, or you can do add component and do search for bullet, find the script, and add it like that. And again, here we can now set our bullet speed to 100. 100. Oh, it does not like if I edit it here. Okay, let's go into the prefab and edit it in here, 100. And bullet life to 2 seconds. And then just Control S to save the prefab. And if we go out of the prefab here, you'll notice it's updated here as well. Cool. So every bullet we spawn in is going to have the speed and bullet life set to these values. Okay, so now we have to actually spawn in these bullets in the world. You could just drag them in, but then there's only one bullet. So if I put this bullet here and click play, one bullet flies off. But we want bullets coming out of our guns when we click space. So I'm just going to delete that bullet we manually placed. And we're going to, through the player script, spawn in these bullets. So for that, we can actually do one sorry. So we need to open our player script, and we'll click that, and we need to at the top add another public game object this time. This is going to be our bullet prefab. So bullet prefab, cool, bullet prefab. And then we need to use this. So in our update here, we're going to do it is an if check. If our player inputs dot player dot fire, remember is the input action we set up, dot triggered, which means that it was just pressed. So basically this checks, was our spacebar just pressed? Then in here we're going to do make our bullets spawn in and shoot. So we're going to do this in a function just to keep it looking neat. So I'm just going to call the function fire. We haven't created it yet, so it'll have squiggly lines. So we're just going to create it down below here. Private void fire. And now, since we just made that function, this will be fine now. And in here, we're going to do some stuff to spawn in our bullet prefab. So we're going to need to set the position of them to be kind of over where the guns are. So for that, we're going to calculate where we want to spawn them. So we're going to do a vector 3 offset, basically the position we want to spawn it at. So offset is going to be our transform dot position of our plane. So that's right in the center of the plane. Plus, in brackets here, we're going to do transform dot forward, dot forward. So relative to the plane, we want to go forward times 2, so 2 units forward, and then plus transform dot right times 3. So this is essentially figuring out our offset. So the position of the plane plus 2 units forward plus 2 units to the right is where we want the bullet to come from. I've already figured it out. That's right where the gun is for our model. So you might need to tweak the value 2 and 3 if your guns are positioned different on your model. And then we're going to spawn in the bullet. So for that we use a function called instantiate, and it takes the parameter first of the prefab, so bullet prefab, and then the position we want to spawn in at, so that'd be offset, which we just calculated above, offset, and then the rotation, which is quaternion dot look rotation transform dot forward, and that is basically just quaternion dot look rotation does a bunch of fancy calculations to get the rotation that the plane is facing. So it takes the direction vector transform dot forward, and this function converts it to a quaternion, which is rotations in Unity. A bunch of fancy math, don't have to worry about it. Just know that this figures out the rotation the bullet needs to be in. And then we're just going to do some setup here for the future. Right here at the end of the bracket for the semicolon, we're going to do dot tag. We're going to set it equal to player bullet, because when we get enemy planes shooting bullets as well, we need to be able to know the difference between our bullets and enemy bullets. So that's why we have that. So I'm just going to copy both these lines because this is the right bullet. We want our left bullet as well. So we just we can move this vector 3 because we're just going to reuse this offset variable. We don't need to declare it. So this time we want to do the left bullet. So we still want to go forward 2 units, but instead we want to go left 3 units. So we're going to put a negative in front of the 3. And it's just going to spawn another bullet and also give it the tag player bullet. And there we go. That should be all the code we need to spawn the bullet. So I'm going to Control S to save, minimize Visual Studio. And we have to set our player bullet prefab on the player game object. So we're going to click on player. Right now it's got none, so we got to go to our prefabs folder and drag in the bullet prefab. So bullet prefab now is the bullet. And now, if we play, and we click space, pew, 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 we are shooting bullets. Now, I'm noticing there's an error in the console here. Error, player bullet tag is not defined. That's because I forgot to actually make those tags exist. So for that, we're just going to go up to the, click on any game object, the player game object is fine. We're going to click on the tag here, and we're going to click add tag. List is empty right now. We're going to make player bullet tag, save that, click the plus again, and we're going to make an enemy bullet tag, and just save that. We're not going to do anything with those tags right now. We just set those tags for the future. And then now if I click play, it should stop complaining. Yeah, it does. Cool. No errors. Awesome.